Come on, everyone, let's do some functions.
Alright, I had to redo this video, so I'm sorry for the bad quality, but the first type of function we are learning about, and the easiest type, is the linear function, which has the same formula as a line, which is y equals mx plus b, but since it's a function, it's fx equals mx plus b. Man, I hate hearing my voice on recording because I have such a deep voice. Anyways, let's make an x and y table for this function that I made up, which is y equals 2x plus 1. Yay! Y table is going to help us graph the function, so we can graph it on a x and y graph. So I drew myself a little x and y graph, also known as coordinate graph. It has lots of other names. And anyways, I'm going to plot on all the points that I drew in my x and y table, which are -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. And you'll notice that they're in a straight line because it's a linear function. Woo! And the slope is 2, so like rise over run, like, yeah, you know, slope is the m, and then the 1 is the y-intercept, which is the b. Yeah. Basically same thing as a line. So you can tell it's a linear function because in the y's, it all goes up with the same amount each time, which is going to be your slope or your m or whatever. But the next function I'm going to show you is exponential functions, and that's not like that. Okay, so exponential functions. There's a completely different formula from linear functions, and the formula is a times b to the x. A times b to the x. Because it's like an exponent. Yeah. So let's make this function. I don't know, let's make it something like 3 times 2 to the x. So let's make a table and we can graph all the x's and y's like we did before, because when you make an x and y table, that's what helps you graph. So yay. Okay, ignore that sound in the background. That's my sister. Right now my x and y graph is done. So what I'm going to do is I'm going to plot my points, which are -2, 0.75, because it's like a negative exponent, which makes it a fraction. -1, 1.5, 0, 3, 1, 6, and 2, 12. And you'll notice that it goes up by a different amount each time, which is what makes it, you know, exponential. But as you can see, each time it gets multiplied by 2. You might notice that our a here is 3, and the y for 0 is 3. And you'll notice that the number is multiplied by each time is our b. So yeah, that is what the formula is. Basically, you can tell it's an exponential function because it is curved in this type of way.
I'm really sorry that this video is so bad. I had to redo it like 18 times because my video program is like crap. Anyways, exponential growth and decay are like 2 different versions of the same formula. And basically the formulas are exponential growth, it's y equals a in parentheses 1 plus r close parentheses to the t, and for exponential decay, it's a in parentheses 1 minus r close parentheses to the t. And the reason why this is because you'll notice that it's very similar to the exponential formula, except for the r and the 1. And the reason why that is that the r is the percentage at which the thing grows or decays over time, and t is the time period, and a is the initial value. Yeah, okay. To give you an idea of what that means, let's have an example. Okay, so here's our example. Say that you have $3,000 in a savings account, and you expect the value of your savings to increase 8% each year. Here's 0, which is the year you put it in. You'd have A, the initial value, which is 3,000, 1 plus R, that's 8%. But added to 1, it's 108% because it's increasing by 8% to the 0 power, which is 1. So it's still going to be 3,000. In year 1, you're going to have 3,000 times 1.0, 8 to the 1. and that's 3,240. Then year 2 is going to be 3,499, etc., etc. And then it'll look like this when you're done. Yay. And now for exponential decay. I bought a new car the other day. I mean, obviously I didn't buy a car. I'm not old enough to drive, but like, okay, let's say Tim bought a car. Tim bought a car for $20,000, and he expected the value of the car to decrease by 10% each year. So how would we graph this function? Oh, we can use this formula here. Oh, look! What's that? It's a formula! Formula Man is here! I'm sorry, I'm trying to make this video exciting, okay? The formula says, for exponential decay, y equals a times 1 minus r to the t. Well, A is $20,000 because, like, that's how much the car cost initially. And R is 10 because that's the rate that it decays each year. So we just have to fill those things into the formula and kazam! Now all we have to do is make an X and Y table and graph it. $20,000. Then we have it decreased by 10%. And we now have $18,000, and we have $16,200, etc., etc. And now we can graph it, and it looks like this. Okay. And that's what exponential growth and decay is. Okay, before I leave you today, we're going to talk about quadratic functions. And so quadratic functions are functions that have a squared, because quad, the prefix quad means square, in case you didn't already know that, because it means like 4 and stuff. Anyways, so in order to show you what a quadratic function is, we're gonna graph y equals x squared plus 4x. And in order to graph the function, first you have to find the axis of symmetry. So basically all quadratic functions go by the same formula. Y equals a x squared plus bx plus c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Now in order to find the axis of symmetry, we'll need to take the formula. The axis of symmetry is negative b over 2a. So let's just plug those in. Negative 4 over 2 times 1 is negative 4 over 2, which is negative 2. So I'll put that in the middle of our chart when we go to graph the x's and y's. So let's write those down, and as you can see, they seem to be following some sort of pattern, and you can see that it's symmetrical around the axis of symmetry, which is why it's called the axis of symmetry. Symmetry, symmetrical. Anyways, when you plot the points out on the graph, it'll make a weird sort of shape. That's called a parabola. Parabolas are fun. Yay! All quadratic functions make parabolas. Sometimes the parabolas are upside down, sometimes they're skinny, sometimes they're fat, but they all make parabolas. Yay, okay. I think that is all the types of functions we will be talking about today. In conclusion, a function is a relationship between input and output, such as this vending machine. Like, you know, when you enter the code is the input, and then the tasty snack you get out, such as goldfish, the snack that smiles back is the output. I actually don't know how to end videos at all, so goodbye, folks, and I hope I'll see you in 9th period math. 9th period math.